Hi everybody, I am Dr. R. Vivekananda, Assistant Professor, Department of Mathematics and Management Sciences. Today the course is Fourier and Complex Analysis, in which the Unit 3 is Integration of Complex Function Power Series. Here the topic is complex integration and integration along line or arc. So complex integration, I am just going to give the introduction on complex integration. Complex integration is nothing but the integration which we evaluated on complex functions. How we evaluated integration real functions, real valued functions. Similarly, we are going to evaluate integration on complex functions. It is interesting to know that some definite integrals involving real variables can be evaluated by simply using integral theory of complex variables. Here, f of z is equal to dz, f of integration f of z dz equals to integration f of x plus y equals to dx plus ity, where z is nothing but x plus iy. This is a complex variable. Okay, and dz, where is dz means differentiation of complex variable, that implies dx plus idy. Okay, and also we discuss Cauchy's integral theorem and their applications in this. Cauchy's integral theorem and applications. No need to discuss proof of Cauchy's integral theorem. Just we discussed the in theorem statement and its application we used to discuss here. We will discuss here. So line integral, what is line integral? Because we are going to evaluate a basic thing, how we find integration of a complex function. So here the line integral or integral along the curve or along the line or curve. See, so f of z is a function of complex variable defined in a domain D. Let C be an arc in the domain joining from z is equal to alpha to z equals to beta. Let C be defined by x equals to a function of t, x is a function of t and y also a function of t, where t lies t takes the values from a to b, and where here alpha is nothing but a complex variable value at a, and b is nothing but a complex variable value at b. And here we are assuming that the variables x of t and y of t are continuous and first order derivatives exist in the interval, a closed interval a comma b. And we define a complex integration f of z dz equals to integration over a to b f of z dz equals to integration a to b f of x of t plus I into y of t into x of t plus y of t dt. So this is the complex integration definition, actual definition. This is f of z, and dz, this is totally nothing but dz, which is equals to like dx plus I dy. So now we are trying to evaluate some, we are going to discuss some examples here. Evaluate integration. So this is real valued function. Let us have to discuss one real valued function, how we are going to evaluate. So based on that we proceed to evaluate integration of complex functions. So now here evaluate integration 2y plus x square into dx plus 3x minus y into dy along the parabola x is equal to 2t and y is equal to t square plus 3 along the line joining from 0 comma 3 to 2 comma 4. Okay, when the parabola x is equal to 2t and y is equal to t square plus 3 along this parabola the points lies. So from the point 0 comma 3 to 2 comma 4 along the parabola we have to evaluate this integration. So now integration 2y plus x square into dx plus 3x minus y into dy. So this integration is happened with respect to two variables. This integration we have to evaluate along the parabola where x is equal to 2t, y is equal to t square plus 3. So let us try to reduce this integrand into t variables by substituting x is equal to 2t and y is equal to t square plus 3. X is equals to 2t, y equals to t square plus 3. So when I take this substitution integration 2 into y, that is t square plus 3 plus x square, that is 2t whole square, into here on differentiation x is equal to 2t means dx equals to 2 dt, and y is equals to t square plus 3 means dy equals to 2t plus 3, right? So here in the place of dx I am going to write 2 dt as per the above information, plus integration 3 into x means 3 into 2t minus y means t square plus 3, which is in braces as followed by minus, so we need to keep that in bracket, into dy is nothing but 2t plus 3, 2t only, sorry, 2t only. So here it becomes 0 na, 3 becomes 0, only 2t, okay. So now integration 2 into t square, 2 into t square plus 6 plus 4t square into dt into 2 dt plus 6t minus t square minus 3 into 2t, the whole thing under dt, the whole thing, so here the whole thing 2t dt na, dy equals to 2t dt, which is equals to integration, so 4t square on multiplying by 2 plus 4 plus 4, 2t square plus 4 is going to be 6t square into 2 means 12t square, 12t square plus 2 6 are 12 plus 2t into 2t, 60 into 2t is going to be 12t square plus into minus 2t cube plus into minus 3 into 2t is minus 60 into dt. Now you try to simplify, minus 2t cube plus 12t square plus 12t square is plus 24t square minus 60, we have only t term, only one term, that is minus 60 for a t term, and the constant term is 12 into dt. So which is equals to, now if I evaluate integration, minus 2 into t cube integration is t power 4 by 4 plus 24 into t square integration t cube by 3 minus 6t square by 2 plus 12t. This is under whole bracket. And here I need to discuss about the limits. When x is equal to 2t, so here the points are, Here the points are 0, 3, the line joining 0, 3 to 2, 4, and x is 2t, and y is t square plus 3, t square plus 3. Now at x equals to at the point 0, 3, at the point 0, 3, x is 0, which is equal to 2t. From this t becomes 0. At the same time, y is 3, which is equals to t square plus 3. That implies t is equals to t square is equal to 0. That implies t is equals to 0. So at this point, the point 0, 3, at the point 0, 3, t becoming 0. Similarly, at the point 2, 4, what happened t value? Let us see. When x is 2t, x is 2, which is equal to 2t. From this t equals to 1. From this t equals to 1. And 4 equals to t square plus 3. 4 equals to t square plus 3. And t equals to 1 it becomes. Means at this point t becoming 1 at this point. So therefore t is varying from 0 to 1. T is varying from 0 to 1. T limits are 0 to 1. That we take for evaluating integration. So now go to previous slide. There you substitute t values as 0 to 1. 0 to 1. Okay. So now go for minus. I will write that one in the next slide. Otherwise here I will write. So minus 2t power 4 with respect to 1 means minus 2 by 4 you will get, plus 24 by 3 minus 6 by 2 plus 12 for the upper limit. Minus 0 for the lower limit. So which is equals to minus 1 by 2 plus 8 minus 3 plus 12, which is equals to 12 plus 8, 20 minus 3, 17, 17 minus of 16 and half, that is 33 by 2. So this is the value of the integration along the parabola joining the point 0, 3 and 2, 4. Okay, next. Go to next one. Evaluate integration x plus y into dx plus x square y dy along the line y is equal to 3x between the points 0, 0 and 3a. Between the points 0, 0 and 3a. See here. Along the line y is equal to 3x. So y, in the place of y you substitute 3x, and in the place of dy you substitute by 3 dx. On differentiation you will get. Y is equal to 3x means dy is equal to 3 dx. Okay. Now I am going to substitute these in the integration, where the integration is provided in two variables x and y. So I am going to take I'm going to reduce the two variables into single variable integrand. So that is x plus 3x into dx. I'm trying to reduce the whole integrand into x variable plus x square into y is 3x, dy is 3 dx. So now integration x plus 3x is 4x plus x square into 3x into 3 is going to be 9x cube on multiplication. That you write under the single dx. Under single dx you can write by taking dx under common. Right. Now I reduce the integrand of two variables into integrand of a single variable of x. Now let us go for discussing the limits for x. Here we need to evaluate integration from the point 0 comma 0 to 3 comma a. So here x limits are 0 to x limits are varying from 0 to 3. 0 to 3. 0 to 3. X limits are varying from 0 to 3. Here x limits varying from 0 to 3. So therefore this integration value calculated from 0 to 3 or integration over the limit 0 to 3, 4x plus 9x cube dx. 9x cube dx. So which is equals to 4x dx means 4 into x square d by x square by 2, because x integration is x square by 2, and 9 into x cube integration is x power 4 by 4, and over the limits 0 to 3, and over the limits 0 to 3. So which is equals to 4 into 3 square by 2 plus 9 into 3 power 4 by 4. 2 ones, 2 twos, which is going to be 18, and which is going to be 9 into 3 power 4 by 4 na 18, which is equals to 18 plus 9 into 3 power 4. 3 power 4 means 3 power 4 by 4, isn't it? The previous side 9 into 3 power 4 by 4. So which is equals to 9 8 72 plus 9 into 3 power 4 means 81 whole divided by 4, which is equals to 72, which is into 72 plus 729 by 4 by 4, which is equals to 11 0 801 by 4, isn't it? 92 plus 11 801 by 4. So if you want to, you can write this in a fractional form 201 by 4. So this is the value of integration. Along the line y is equal to 3x between the points 0 comma 0 to 3 comma a. Right. Similarly, one more sum we will discuss, one more example. So here complex integration I am entering into. In the previous examples I took for the real valued functions, real variable functions I took. In the similar way, how we evaluate complex integration, in that for that only previous examples I discussed. This is a complex integration. This complex integration similarly we can practice, we can proceed, or we can do as per previous ones. Okay. Now integration 0 to 1 plus I x square minus Iy into dz into dz. Dz means what I said? Z equals to x plus Iy. This is the variable. Dz is nothing but dx plus I dy. Dx plus I dy. So in the place of dz, I'm writing dx plus I dy, which is a multiple term. So I just keep in bracket. Okay. So now you try to simplify this. So here along the line y is equal to, along the paths y is equal to x. Na? Let us try to evaluate integration along the path y is equal to x. So y means y, that implies dy equals to dx. Dy equals to dx. Use this concept. You try to reduce the above. You try to reduce the above integration into single variable, that may be in x or y. So now I'm going to reduce the double integration. I'm going to reduce the above integration into single variable integration, that is x square minus I into y is given by x into dx plus I into dy is also nothing but dx. And about limits, here we have 0 to 1 plus I, na? 0 to 1 plus I. 0 to 1 plus I means 0 plus I0 to 1 plus I. 1 plus I means 1 into I. Means here the point 0 comma 0 to 1 comma 1. So this is x limits. This is x limits. And these are all y limits. Now I reduce the given integration into x in terms of x integrand function. So you take x limits, that is 0 to 1. Here x limits are varying from 0 to 1. X limits are varying from 0 to 1. So I'm taking integration 0 to 1. X square minus ix into dx. Into dx, I am taking dx common from these two terms, and 1 plus I. When I take dx common, 1 plus I will be left. That 1 plus I is a constant with respect to integration. With respect to integration, it is independent of x term. So I bring it outside. Okay, I bring it outside. So now here, which is equals to 1 plus I integration 0 to 1 x square minus ix into dx, x square minus ix into dx. Now perform integration. 1 plus I x square into dx is x cube by 3 minus I into x dx integration is x square by 2 over the limits 0 to 1. Over the limits 0 to 1. Okay, because we had limits 0 to 1 of x limits are defined 0 to 1. So then which is equals to 1 plus I into, with respect to upper limit 1 cube by 3 minus I into 1 square by 2. Minus lower limit. For lower limit, x cube 0 and y x square also 0. So totally for the value is going to be 0. Okay, the value is going to be 0 for the lower limit. So 1 plus I into, what will be here? Here we'll get 1 by 3 minus 1 by 3 minus I into 1 square by 2 means I by 2. That's all. This is the solution. This is the solution. This is the way of finding integration for complex functions. For complex functions, we find the integration. As similarly real valued function, how we evaluate integration, no? In the same way, you evaluate integration for complex functions also. Let us go for one more sum, one more example. So here, integration 1 minus I to 2 plus I. 2x plus 1 iy into dz along the line joining. 1 comma minus 1 to 2 comma 1. Okay. So let us try to. So here, solution, integration 1 minus I to 2 plus I. 2x plus 1 plus iy into dz. I already said in previous sum, z equals to x plus iy, z equals to x plus iy, dz equals to dx plus I dy, dx plus I dy. So I am taking here dx plus I dy. This integration we have to evaluate along the line joining. So along the line joining, along the line joining, along the line joining, 1 comma minus I, minus 1i, 2 plus 1i is nothing but 1 comma minus 1 to 2 comma 1. Along this line, we have to evaluate this integration. So along this line means first let us try to evaluate the line equation. Okay, the line equation. So if I take this as the point A, this is the point B, then the line equation AB, the line AB is equals to, the formula is y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. This is the formula we had for 2-point formula. The line equation for 2-point formula is y minus y1 equals to y2 minus y1 by x2 minus x1. What is x1 y1 x2 y2 means? You represent them as these points as x1 y1. You represent these points as x1 y1. This is x1 y1. This is x2 y2. You represent like that. Then you substitute. Now you substitute. So y minus y1 means y minus 1. 1 means y1 means minus 1 is equals to y2. y2 is 1 minus of minus 1. y1 is minus 1 by x2 is 2 minus x1 is 1 into x minus x1 is 1. So this implies y plus 1 is equals to 1 plus 1 by 2 minus 1 is that is 2 into x minus 1. Now you try to simplify this. Okay, what do you get here? Y equals to 2x minus 3. On simplification, we will get y equals to 2x minus 3. This is the line equation we are getting. Y equals to 2x minus 3. So we have to evaluate along the line, along the line y equals to 2x minus 3. Here y is on differentiation, what do you get here? dy equals to 2 into dx. So similarly, I am going to reduce the given integrand into single variable by substituting that. So what is the given integrand? 2x plus 1 in plus iy, 2x plus 1 integration, 2x plus 1 plus iy into dx plus I dy. Okay, now I'm going to substitute y by 2x minus 3 in this. So integration 2x plus 1 plus I into y is 2x minus 3, 2x minus 3 into dx plus 2 dx plus I into 2 dx. Okay, I reduced the double variable integrand into single variable integral, that is in terms of x. So that is 2x plus 1 plus I into 2x minus 3 into dx. When I take dx common, what will be left here? 1 plus 2i will be left. That 1 plus 2i I am writing outside. That 1 plus 2i I am writing outside. Now we have to take the limits for this. So here the line is joining from 1 comma minus 1 to 2 comma 1 na? So that implies x limits are varying from 1 to 2. X limits are varying from 1 to 2. So therefore this integral is evaluated over the limits 1 to 2. So which is equals to 1 plus 2i into 2x integration is 2x square by 2 plus 1 into dx integration is x plus I into 2x dx integration is 2x square by 2 minus 3 into dx is 3x. So over the limits 1 to 2, over the limits 1 to 2. Okay, so now I will try to simplify here. So which is equals to 1 plus 2i into when I put upper limit, these 2 to get cancelled here. So only x square will be left. Even here also 2 to get cancelled, only x square will be left. X square for upper limit is going to be 2 square plus 2 square plus 2 plus I into 2 square minus 3 into 2. This is totally for upper limit. Minus lower limit 1 square plus 1 plus I into 1 square minus 3 into 1. And close the big bracket. So then which is equals to 1 plus 2i into 2 square means 4 plus 2 is 6 plus I into 4 minus 6 is minus 2 This is totally for upper limit. Minus lower limit. 1 square plus 1 is 2. Plus 1 square minus 3 is going to be minus 2i. Is going to be minus 2i. Close the big bracket. So which is equals to 1 plus 2i into 1 plus 2i into, you simplify, 6 minus 2 is 4, minus 2i plus 2i is going to be 0. This minus 2i and this minus 2i is going to be get cancelled as they are under subtraction. So this, which is equals to 4 plus 8i, is the integration of the given complex integration. For this the integration is this one. Like this you need to discuss, you need to practice. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.